Welcome back. Welcome to our power system lecture series. Today, we are going to study and analyze the per unit system of a single phase transformer. In a previous session, we discussed and we analyzed ideal transformer, single phase ideal transformer, single phase practical transformers. Today, let's look at the per unit system. Let's start with the definition of the per unit system. Let's get the pen. Ready? What's a per unit system? The per unit system definition. The per unit is equal to actual value divided by the base value. Based on these definitions, I need to define the base value of every single element. For me, I'm interested into voltage, current, power, impedance. So I have to define the base voltage. The base voltage, always a real number. The base voltage must be always a real number. This is very important to keep it in mind, that the base value always a real number. The angle of the per unit is the same as the angle of the actual. So the angle of the per unit, I want to call it PU, is always the same as the actual value. As the actual value. Now, when I decide to do a per unit system, I define two elements. I define V base and S base. So I define V base and I define S base. And then I can derive the rest. I derive from these two, I can say Z base, it's equal to, remember S, P, the power, it's a V squared divided by Z, which is equal to V base squared divided by S base. And I base equal to S base divided by V base. So as soon I define these two values, I can derive Z base and I base. I can define Z base and I base. Now, let's By conventional to make our life easier, we will adopt the following values for the base. S base is the same for the entire power system of concern. If I have a power system, I choose one S base for the entire system. So I have S base will be chosen for the entire system under assessment. The entire system under assessment, I have S base locked in. For a voltage, when I come to a transformer, that's what I want to learn today, because this information we already studied in the previous chapter. Now, for a transformer, what do I have in a transformer? This is my transformer. I have two sides. I have V primary and I have V secondary. Is that clear? So now what I do for the transformer, I have to set up like a virtual line. I will set up V base on this side and V base on this side. V base on this side is equal to the rated power of V primary. This is the rated voltage at the primary side. V base on the second side will be Vs, and this is the rated voltage at the secondary side. If I have no transformer, if I have a voltage source supply a load through a transmission line, I have one voltage base. When I have transformer, I have to distinguish between either side, the high side or the primary side, and I need to distinguish between the secondary side of the transformer. I hope that's clear. That's how I set up my system. Now let us do an example. I just want to do a quick example to see the benefit of my per unit system. I have an example. I have 20 kVA, 480 to 120 volt transformer. It's supplying a load. The equivalent leakage impedance at the transformer referred to the secondary. So now I have Z2 equivalent referred to the secondary. The value is given 0.0525. The value is given 0.0525, angle of 78 degrees. That's the equivalent leakage impedance of the transformer referred to the 120 volt windings. I need to use the rating of the transformer. Using the transformer rating as a base value, determine the per unit leakage impedance referred to the winding 1 or 2. So now this system, if I want to sketch this system from my previous video, I have that's Z2 equivalent. This is my 400, this is my 480 volt, this is my 120 volt. I hope that's clear. Now, I need to find the per unit system of this Z equivalent as seen from the primary and as seen from the secondary. As seen from this point and as seen from this side. Okay, let's do the calculations. Number one, what I have to do is I have to define what's S base. Let me write Z2 on this side so I can keep it. It's equal to 0.0525, the angle of 78 degrees. This is my Z2. Now, I have my transformer. Remember, I have my transformer. I want to represent it like this, so I can put it on the board. And on this side, I have on that side is 480 volt. On this side is 120 volt. Based on what I said before, I have to define S base. So I'll define, let me use different color. I have S base will equal to 20 kVA for the entire system. Because I have a transformer, I have to put V base 1 on this side, and I have to define V base 2 on this side. Because I have a transformer, I have to distinguish between these two. This V base, I use it to be 480 volt, the same rated value. For this side, I use 120 volt. I have one base for the entire system, and then what I have is I have two base voltages. This will give me two base impedances. So let's put Z base 1, it's equal to V base 1 squared divided by S base, divided by S base, and Z base 2 and Z base 2, it's equal to V base 2 squared over S base. So now this will give me, the answer will be 0.72 ohm. 0.72 ohm. And for Z base 1, the answer will be 11.52. This will be 11.52 ohm. All I did is I divide 480 squared divided by 20,000. I divide 120 squared divided by 20,000. Is that clear? Where is Z2? Z2, this Z2 equivalent is located on the secondary side. So now to convert it into per unit, Z2 as seen from the secondary side, per unit it's equal to Z2 equivalent per unit. It's equal to actual divided by base. It's equal to 0.0525 angle divided by 0.72. I applied the equation. Actual divided by base. Z2 equivalent base per unit on this side. I divide it by Z base 2, which is 0.0525 divided by 0.72. The answer will be 0.0729. 0.0729. It's the same angle as we mentioned. Same angle, 78 degrees. Did not change. Did not change whatsoever. Great. This is the Z equivalent per unit as seen on the secondary side. The question is, I need to find it on the primary side. I recall the equation. I will recall the equation from the transformers, and will tell me Z on this side it's equal to A squared times this Z. So now I will recall these equations. Let me delete this side. I have all my answers here. I have Z equivalent 1 as seen from the primary. It's equal to A squared multiplied by Z equivalent on the secondary, which is equal to 480 divided by 120 squared multiplied by 0.0525, the angle 78 degrees. So Z equivalent 1 will be equal to 0.84 angle of 78 degrees. Now, Z equivalent per unit 1 per unit, it's equal to the actual, which is 0.84 angle of 78 degrees divided by Z base 1. And Z base 1 was 11.52. We found it 11.52 on. The answer will be 0.0729 angle of 78 degrees. Wow. Which is equal to Z equivalent to per unit. Therefore, the per unit leakage impedance remain unchanged when referred from the winding 1 or 2 when it comes to the per unit. See, that's one of the advantages for the per unit. The same per unit will apply the same value. If I look at it from this side or that side, I will have the same value. It will not change for me at all. Now, let's recap what we did and we finish this session about the per unit. When I have a system, I will have a transformer. Let's say I have one transformer. I have another system, I have another transformers, for example. S base, when I do the per unit, S base is the same. S base is the same for the entire system. However, when it comes to my voltage, in this system I have a 3 V base 1, I have V base 2, I have V base 3. I have Z base 1, Z base 2, Z base 3. So what does a transformer do to my per unit circuit? It will divide it on the primary side, on the secondary side. Look, in this second example, I have another transformer. This also will divide it into another base. Okay? I hope that's clear. And let's now do an example together.